Welcome to Fiberstar Citri-Fi Citrus Fiber and Baked Fillings webinar. There will be two speakers today. I'm Dan O'Connell, Vice President of U.S. Sales, and we'll talk about Citri-Fi and why it's an ideal functional fiber for bakery filling. My colleague, Sheila McWilliams, will then review several bakery fillings case studies to demonstrate the formulation and benefits. Dr. Brock Lundberg will handle the technical questions that you may have during the question and answer session. You can enter questions at any time during this webinar. The webinar is muted to provide you the highest audio quality. After the webinar, there will be a short survey. Please fill out this to help us improve future webinars. Also, this webinar will be recorded and sent to you via an e-blast. Citri-Fi provides multiple benefits to a variety of bakery products. Because of this, we're hosting a series of webinars focusing on different topics. Listed here are a few potential topics, including clean label emulsifier, replacement, gluten-free, snacks and biscuits, and egg and oil reduction. Last month, we hosted a webinar about moisture management in baked goods using Citri-Fi. If you're interested in this recording, please contact us. Citri-Fi provides a variety of benefits to bakery items. The biggest selling point is its ability to bind water and naturally emulsify. These are two key functions that improve a variety of bakery fillings. The high water holding helps reduce filling separation. The dual functionality creates fillings that are heat, pH, and freeze-thaw stable. Using this natural ingredient also eases handling and processing, in addition to creating superior textures. In addition to the functional benefits, Citri-Fi citrus fiber supports bakery positioning in a number of ways. For instance, Citri-Fi is allergen-free and gluten-free, which is ideal for gluten-free bakery. Citri-Fi's labeling options include citrus fiber, dried citrus pulp, and citrus flower, which resonate well in the clean label markets. Citri-Fi is plant-based, which fits vegan and vegetarian bakery products. And Citri-Fi also contributes fiber, which improves the nutritional profiles. Lastly, this citrus fiber is non-GMO and has no E number. Citri-Fi can be used in a variety of bakery fillings, including fruit-based, cheese-based, cream-based, and even meat-based. Here are a few commercial examples on the marketing using citrus fiber. There are a few Citri-Fi products that we recommend in bakery foods. The 100 line is strictly citrus fiber. For certain applications that require additional viscosity, we recommend the 200 line, which is Citri-Fi co-processed with guar gum. There are a few ways to incorporate Citri-Fi into baked goods. The most common way is to mix Citri-Fi in with dry ingredients such as sugar. Another method is mixing Citri-Fi and water. However, this method is not commonly used. The Citri-Fi needs to be mixed into the liquid with strong agitation to prevent clumping or fish eyes. One other method is to mix Citri-Fi in oil before mixing with other liquids. We typically recommend using Citri-Fi between 0.25 and 1% based on total formula weight. Depending on the bakery application, additional water is needed and is recommended at 3 to 8 times the weight of Citri-Fi. As mentioned, Citri-Fi is added using one of the previous mentioned methods. Extra water is added with the rest of the water in the formulation. And in some cases, Citri-Fi can be mixed with sugar first if there is a creaming step. Here is a detailed list of different bakery applications and their respective usage guidelines. Though we have several Citri-Fi products in our portfolio, the ones listed here are a good starting point for each application. So, I mentioned that water binding and emulsification were two key benefits of Citri-Fi in bakery products. However, you're probably wondering why that is. First, Citri-Fi is created from a byproduct of the citrus juicing process. Today, these upcycled food ingredients are a hot commodity due to the sustainability initiatives. Here, the citrus fiber starts life in a citrus fruit. After going through a physical process that is free from chemical modifications, the citrus fiber opens to provide high surface area. This lends itself to high water holding capacity. You can see the expanded surface area in the images on the right. Not only is the high surface area key to high functionality, but so is composition. Citri-Fi typically contains around 70% dietary fiber, which is comprised of soluble and insoluble fiber. The soluble fiber attracts and adheres to water, creating viscosity. The insoluble fiber provides the structure to hold the water indefinitely. Keep this in mind when working with bakery applications that are subjected to harsh processing conditions, such as freeze-thaw. The protein helps provide the fat and oil binding, especially in emulsions. Here are a set of photos demonstrating Citri-Fi's ability to swell and hold on to water over time. The appearance becomes more gel-like as time moves on. Hydration is important to make sure that the Citri-Fi is fully activated and functional. Full hydration typically occurs around 5 minutes. In some bakery processes, there may be some form of shear. However, in this test, you can see high shear creates additional viscosity. Though this type of shear is not commonly used in bakery processing, the point is that low shear does occur and will not likely create additional viscosity, which could adversely affect the process. This is great for bakery systems that do not need additional viscosity. Temperature differences did not affect the water binding. Citri-Fi holds up to 10 times its weight in water. Here, we demonstrate Citri-Fi's water binding power. Citri-Fi is used at a very high usage level, not typically used in food applications. It helps showcase its binding ability. During the mixing, the fiber swells to create viscosity, and the Citri-Fi continues to hold that water even during harsh processing conditions. Citri-Fi's ability to emulsify is due to a few factors. As mentioned before, the high surface area helps lock in oil droplets, which is more of a physical process. Another mechanism explained here involves the high pectin content that Citri-Fi contains. Pectin's molecular structure enables Citri-Fi to bind water and oil, which further strengthens the emulsifying action. Citri-Fi's native intact pectin content sets itself apart from other citrus fibers in the market. Because Citri-Fi does not have an HLB value due to its alternative emulsifying mechanisms, Fiberstar created a stabilizing index which helps compare various commercial emulsifiers on the market. Here, you can see that Citri-Fi was compared to oat fiber, lecithin, carrot fiber, and monodiglycerides. Due to the clean label demands and supply constraints, some manufacturers are seeking alternatives to lecithin and monodiglycerides. You can see that Citri-Fi stabilizes 2 to 3 times more oil than lecithin and 1 to 2 times more than monodiglycerides. When we meet with customers, we enjoy showing Citri-Fi's emulsification properties by using this demonstration. This demo uses oil at 3 times the Citri-Fi weight and water at 10 times the Citri-Fi weight. Citri-Fi is mixed into the oil first. The fiber surface area opens up to trap oil when mixing starts. Then the water is added. In a closed jar, the mixture is shaken until the swooshing sound goes silent, which is when the emulsion is formed. This is due to the water hydrating the fiber, which causes it to swell and create viscosity. This emulsion has been left out for weeks without breaking, which further proves Citri-Fi's ability to create natural, stable emulsions. Now that you understand Citri-Fi's benefits and the mechanisms that create these functionalities, I'm going to hand this off to Sheila McWilliams so she can provide more detail about how to use Citri-Fi in a variety of bakery fillings.
Thank you, Dan. Before we look at the first case study, there are a few points from each example that I want to be sure everyone captures. First, the benefit we hope to achieve along with actual results. Second, the incorporation method of Citri-Fi. And third, whether we've added additional water along with Citri-Fi in the formulation. In our first example, we have a basic formula for a fruit pie filling. This is a filling that can be used in a pie or a tart, cobbler, Danish. The objective of this study is to prove that Citri-Fi is effective at binding water, which is basically the fruit juice, to improve the consistency and performance of the fruit filling without adding starch. The control formula contains a little over 3% cornstarch. The test formula uses Citri-Fi 100 Fg at 1% without any added cornstarch. All the dry components, the sugar, the Citri-Fi, the salt, are first blended well and then tossed with the fruit and added to the pie crust. The photos show two pies, which look very similar until sliced. The pie containing just cornstarch is wet, it's weeping juice, and has a very loose structure. Citri-Fi in the second pie binds the juice from the berries, so there's no weeping when sliced. The slice is very clean, and the remaining pie stays intact. The texture of the pie containing Citri-Fi is not a rigid gel. It's not jelly-like. It's just a lovely, cohesive, soft structure. Our next case study is a lemon pie filling. A very standard recipe using eggs and cornstarch for thickening and with added butter for flavor and richness and texture. The objective is to determine the impact Citri-Fi has on stability and texture. In the Citri-Fi version, we're using 140, which has a finer particle size than the 100 Fg we used in the fruit filling. So if you make a filling with particulates, so large berries, it may have some seeds or a crumbled meat, you can use a larger particle size Citri-Fi like the 100 Fg. But because in this formulation, we're making a very smooth, creamy textured filling, we've chosen to use the smaller particle size Citri-Fi, the 140 at 0.3% usage rate. This is a lower usage rate than the last example. Citri-Fi is not being added to this formula to bind an excess of water or juice, but for improved texture, emulsification, and stability. The Citri-Fi is first blended with the dry components before adding to the lemon sugar slurry, and there is no additional water added. The pies are very similar in appearance. The filling made with Citri-Fi is thicker than the control, so the surface shows a bit more texture than the control pie. These photos show the difference in texture. The control formula is more thin, has less body, and the filling with Citri-Fi is thicker, more body, more set. Both formulas have equally great flavor, but from a sensory perspective, the control texture is soft. It has a very quick melt on the palate. It does not linger. But the Citri-Fi version is creamy. It has a lot of body, and it is a more decadent texture. For a less thick texture, you would simply reduce the usage rate of Citri-Fi, so maybe add 0.2% instead of 0.3. The lemon filling with Citri-Fi will hold up well as a pie filling, as we've shown, but also in a Danish or a cake filling. Citri-Fi is acting as an emulsifier because the recipe contains a fat, basically butter. It's also adding texture, and it will also provide wonderful freeze-thaw stability if the pie is frozen. There is no need to add extra water to the filling. Citri-Fi is at a low usage rate of 0.3%, so no additional water is needed. This example is a pumpkin pie filling, a popular flavor and dessert filling in the US. This formula is based on a standard recipe using canned pumpkin. The objective of this example is to show how Citri-Fi binds water to prevent syneresis and contributes to a cohesive texture and overall improved quality. The control formula uses whole eggs for binding structure and texture. And we have two examples with added Citri-Fi. First, a version with Citri-Fi 140, full egg and added water. The second is a formula with Citri-Fi with 50% less egg and added water. I want to elaborate on the added water. The use rate of Citri-Fi is higher, so we've used 0.5%. So we have added water to prevent the filling from becoming too dry. So if this were a dough, we would talk about the dough becoming too dry, very tight, and having a negative impact, say on low volume. A filling can also become too dry, so we've added extra water. The additional water also supports the hydration of Citri-Fi. As Dan mentioned, Citri-Fi needs water. It needs to be hydrated to see full functionality. If frozen pumpkin is used in place of the canned version, which is very typical in a larger manufacturing situation, no extra water would be necessary because the frozen pumpkin will have free water, free juice, just like the pie filling that we previously reviewed. So it would not be necessary to add extra water to the formula. The Citri-Fi is again blended with the dry ingredients, the sugar and the spices before being added to the pumpkin base. The baked pies are pictured in this slide. The control is visually very different than the two Citri-Fi versions. The control filling is cracked with liquid on the surface. Here is a close-up photo comparing the control formula and the one with 50% less egg. The cracking and weeping are very visible in the control formula. The test version with 0.5% of the 140 is smooth. It's uniform. There's no cracking. The Citri-Fi is binding the water and preventing liquid from forming on the top of the baked filling, even with the addition of extra water. The sliced pieces look very similar. The pumpkin filling is a little more dry in the full egg Citri-Fi version. The 50% reduced egg formula is moist but cohesive with good body and flavor. And the overall quality of the Citri-Fi version is improved because of the elimination of surface cracking and syneresis. This case study is a cheesecake filling. The objective is to replace 30% of the eggs with Citri-Fi 200 FG. Our 200 FG product is a blend of citrus fiber and guar gum, making it a great choice to stabilize the filling and add viscosity and texture. The Citri-Fi is again blended with the dry ingredients before mixing with the cream cheese. The Citri-Fi version is less oily, more fluffy, similar in flavor to the control. The Citri-Fi is acting as an emulsifier, so it's holding the water and oil and stabilizing the filling. The control formula has a more oily crust and more oil in the bottom of the pie pan compared to the Citri-Fi version. The citrus fiber guar blend provides a lovely body, a creaminess, a cohesiveness to the filling. The reduced egg version has improved stability and improved texture. We realize that chefs and product developers may work with savory fillings too. So for the next couple of examples, I'll review a cheese and a meat filling. As you've seen in previous examples, Citri-Fi does provide creamy texture to fillings, so it is a natural ingredient to be added to a cheese filling. In this study, we are providing an option to reduce or extend cheese in a filling and still have a creamy, smooth texture with optimal mouthfeel and flavor and stability. In this study, we are comparing Gouda cheese to approximately a 20% reduction in cheese. The cheese is replaced with Citri-Fi 100 FG, margarine or butter, and milk. The Citri-Fi is blended in at the end of the recipe with agitation to form a smooth cheese matrix. The Citri-Fi in the cheese filling is stabilizing the oil and providing a cohesive, soft texture with less spread. The cheese is still firm, it's still thick, and delivers a Gouda flavor. Using Citri-Fi to extend cheese provides a significant opportunity to cost reduce a filling without sacrificing flavor and texture. Citri-Fi works well in meat fillings. Citri-Fi manages water holding, is a natural emulsifier, and provides a cohesive meaty texture in meat-based fillings. In this example, we've added Citri-Fi 200 at 1% along with extra water. Citri-Fi is emulsifying the fat and water, stabilizing and providing a homogeneous, cohesive mixture. There is less water and less fat loss, which improves the filling yield. And the filling can be used, say, for example, in an empanada pastry with improved quality and reduced moisture migration to a pastry crust. We want to thank you for attending this webinar. And if you need additional information, please visit our website at fiberstaringredients.com. We also have a video library that is very helpful. And if you need further assistance, please contact anyone here on this slide and we will follow up with you promptly. Thank you. Now we will move on to a Q&A session with Dr. Lundberg, and he'll take the first question.
Thank you very much, Sheila and Dan, for those insights. Very informative. So I want to start with some of the questions that are coming in.
So the first question we have has to do with replacing lecithin or monodiglycerides in the bakery application. So can Citri-Fi replace lecithin or monodiglycerides in bakery applications? Is it a cost of use better, or is it more expensive than conventional emulsifiers?
Yeah, Citri-Fi actually has been shown to replace several different types of emulsifiers, including monodiglyceride and lecithin in bakery. And the reason for this is because Citri-Fi is able to hold 6 to 8 times its weight in oil quite effectively. And the monodiglycerides typically would hold much less, 2 to 3 times less, the same with lecithin. And therefore the cost and use becomes quite effective. And by binding the oil and jointly the water, Citri-Fi is able to provide a very smooth mouthfeel and maintain moistness and the crumb texture. And this has been a really effective application. for the emulsifier replacement in many different types of baked goods as well as other applications. Okay.
Okay. The next question has to do with fat-based cream filling. So can Citri-Fi function in a fat-based cream filling with no or minimal moisture?
Well, I can start. Feel free to jump in, but Sheila, although you didn't exactly cover a cream filling, if there are other polar types of syrups that are used, a corn syrup or other types of syrups, other ingredients that could swell the Citri-Fi, then it can be quite effective as an application. However, if there's zero moisture from any type of syrup, typically a sweetener would be used. It's going to be more challenging. Citri-Fi does require some moisture, but it doesn't necessarily need to be in the form of just water. It can also be other types of syrups or come in other forms of where the moisture could be coming from other ingredients. But it does need to be swollen to be really fully functional. And if it's not swollen or hydrated, there definitely is a reduction in functionality. And there's also a time element. The less water that's present, the longer the time will take for hydration. But that could be another tactic to use, either shear or allow for more time of hydration when there's no or minimal water available. And but there's some strategies to help maintain or help improve hydration. And another trick that sometimes we do is just any ingredient that has some moisture, to try to incorporate that with a Citri-Fi very early in the mixing process, just those ingredients to allow extra time. That can be another tip that we recommend. But yeah, those are definitely very interesting applications. There are ways to work around the low moisture fillings.
Okay, great. We have another question. This one has to do with egg replacement. What has been the highest egg replacement in bakery formulations using citrus fiber?
Typically, I guess in most of our recommendations, we're in the 15 to 20 or 25% range. That's the most common. The Citri-Fi is quite effective at emulsification, and that's part of the functionality that it is duplicating or replacing when eggs are reduced. But the full functionality of eggs, Citri-Fi and eggs are quite different in terms of some of their mechanisms for the full functionality. And it would take typically other ingredients to do more replacement, other ingredients besides just Citri-Fi and water, other emulsifiers or other denaturing ingredients that function similar to eggs would just be some examples of other ingredients. We certainly do have customers that have replaced 100% or 50% or 100%, and it is possible. And part of it depends on the amount of eggs that are in the formula and the function that those eggs are performing. If it's primarily emulsification, then there's a better chance of, or easier chance of more egg reduction. So it depends a little bit on the formula, but and the functionality that the eggs are being used for, but there certainly is possible to do more than that 20%, but most of our safe recommendations are in that 20% range.
Okay, thank you. The next question has to do with water activity. Does Citri-Fi impact the water activity? If so, can it reduce it?
That's a very good question. We do hear that a lot. It's a question that that we oftentimes have from data. We don't actually have it as part of this webinar today. We have covered it in prior webinars, but water activity typically would not be reduced with Citri-Fi, but it's typically maintained throughout a bakery product when Citri-Fi plus additional water is used. It is bound by the Citri-Fi when additional water is used. However, Citri-Fi isn't a small molecule that is able to reduce water activity. It doesn't dissolve, and the molecule is too large for it to really be effective at water activity reduction. The typically it would take a syrup or salt or something that some type of sugar would be more conducive for water activity reduction rather than Citri-Fi. However, in many of the formulas, we do show the how water activity can be maintained when Citri-Fi is incorporated. So maintained as a control, similar to the control for water activity for which is important for shelf life.
Great. The next question, it has to do with pectin in fruit prep. So can Citri-Fi replace pectin in fruit preparations?
Yeah, Citri-Fi does have a significant amount of pectin, 35 to 40% native pectin. The pectin that's contained within Citri-Fi is typically is more in the native form. It's intact. It's more of the high methoxy pectin. So if there's a couple different ways to go about pectin replacement using Citri-Fi, because of Citri-Fi being high methoxy, typically high methoxy pectin would be quite similar, just using a similar or similar amount of pectin within the Citri-Fi. If it's 35 to 40% pectin, you try to use and adjust the amount of Citri-Fi to maintain the pectin content when it's replacing the high methoxy pectin in a high sugar and low pH fruit preparation would be one example. And in that case, it can be quite straightforward, but you also had advantages of different particle size with Citri-Fi that can be used to adjust texture and mouthfeel. And one other difference with Citri-Fi is it tends to be more heat stable compared to an HM pectin, typical purified HM pectin, which typically they're not, and that heat stability has many advantages and oftentimes can be used just for heat stability alone. And it can be used in conjunction with pectins. So there are ways to actually do LM pectin reduction too, and that's something that probably we could just work individually, but there is that potential as well for the LM pectin. So certainly there is potential, but there are differences, and Citri-Fi isn't going to be completely clear or dissolve in solutions. And so that also brings up some either pros or cons depending on the different application, but definitely reach out to us and we can discuss that more.
Okay, great. The next question, can Citri-Fi be used in condensed milk in a filling?
Sheila, feel free to jump in on this one too. But condensed milk, I mean, we certainly have worked with condensed milk applications, and the key is just hydration. If Citri-Fi is hydrated, definitely there are many potential opportunities for using Citri-Fi in conjunction with the condensed milk, providing the emulsification, replacing other stabilizers or emulsifiers. So definitely there is potential in a wide range of applications with condensed milk.
Yes, you're absolutely right, Brock. And I think we actually have a starting formula using Citri-Fi in a condensed milk application for a filling. And the other thing that I want to be sure we add, because I'm not sure that we covered it deep enough, was the shear stability of Citri-Fi. Citri-Fi works really great under shear and actually kind of improves in functionality. And you'll get almost a higher hit on viscosity if you shear your filling. So I know having worked in the bakery industry, sometimes you make up a filling and you put it through your processing and it doesn't look the same, right? It's not the same consistency or viscosity when you're filling it into your pastry or your finished product. And what you'll find with Citri-Fi is it adds great stability, great processing stability, even during shear, and actually improves with shear. So I want to be sure we talk about that too, Brock.
Yes, very good point. In a lot of applications, in fact, shear can be a way to really further enhance or expedite functionality. And it doesn't break down with shear like many other ingredients will.
Great. So we have another question about fruit filling. So does Citri-Fi work in baking stable fruit fillings?
Well, yeah, definitely. That is a really great application for Citri-Fi because of its heat stability. It's been used a long time by many customers, going way back many years, just for that aspect to provide heat stability, either in conjunction with other hydrocolloids or as a replacement of them. There's a wide range of heat stable examples that tend to be can either be fruit based or other types of vegetable, meat fillings. And we covered a few examples, and what Sheila covered today in this webinar are just a few select examples, but there's many others as well. And we would have application studies in many different applications in addition to what we've covered today that we'd be glad to share. So this is certainly a good application, and baking stability is a really good example of where Citri-Fi can be used.
Yes, Brock, I think that's one of the huge advantages of using Citri-Fi in a filling is there's no bake out. So we were talking more about pies today, and there was a lot of pie examples and such. But if you talk about a cookie where you still have a pastry and you still have a dough, but you have a fruit filling, Citri-Fi is not going to bake out if you add that to, say, the cookie ahead of time and then bake it through the oven. It's going to be very, very stable. So I know in manufacturing, there's always issues with the fruit filling where it's baking out on the sides, it's getting on the oven band, it's causing, a mess, or there's just inconsistencies. You're manufacturing and one day it's very stable, there's no leakage, no breakout in the product, and then, the next week, you have a lot more quality issues. That's a huge advantage of using Citri-Fi in a baked filling, a baked fruit filling. Is it the consistency, the no bake out, the heat stability? So keep that in mind too.
Thank you, Sheila. We have a couple more questions. This one's on egg replacement again. So in your experience, what is the max quantity of eggs Citri-Fi can replace in a cheesecake filling?
Do you want to try to start on this one, Sheila, since you worked on the egg replacement in this filling?
Sure, absolutely. So I think in our example, we looked at 30% egg replacement. You could try up to 50% egg replacement, and it would be a balance of maybe increasing the amount of Citri-Fi you're adding and dropping down in your egg and adding in a little bit additional water. So it's definitely possible in fillings. I think we recommend typically lower egg reduction if you're making in a crumb product. So if you're making a cake or you're making a bread, maximum replacement of eggs is kind of in that sweet spot that Brock talked about, 20%, and you can probably increase it from there. But in a filling, I think you're more likely to get a higher egg reduction. So we showed a 30% reduction in the cheesecake. We showed a 50%, I think, egg reduction in the pumpkin pie filling. So it's just a matter of balancing out your use rate of Citri-Fi in your formulation, lowering your eggs, be sure you still get the emulsification you need, and then adding in additional water.
Great. We got 2 more questions. The next one has to do with flavor. So is there any impact of flavor when Citri-Fi is added? So for instance, can it deliver sweetness?
Well, Citri-Fi is washed quite well throughout our process, so the flavor impact is typically quite minimal. We do have a small amount of residual sugar in the range of 5 to 6 or 7% sugar in Citri-Fi. However, that percentage is low enough that it doesn't typically impact sweetness in the final application. The mixing procedure can also make a difference, but we do try to incorporate the Citri-Fi in early to the process to help minimize any flavor absorption. It's one of the common recommendations that we have. Just in the mixing procedure can make a difference in flavor. And but as far as sweetness, generally it's a pretty minimal sweetness contribution. But I mean, certainly there are some residual sugars within Citri-Fi just naturally occurring from the citrus fruit. Even though we do wash out the flavors and the sugars, there are some residual sugars left, but it's relatively small.
Okay. And we have one more question. This one has to do with viscosity. So this customer asked, does viscosity of Citri-Fi change over time, like when they're working with tiramisu type applications?
Yeah, good question. Citri-Fi, once it's hydrated, is quite stable. The viscosity doesn't change. That's one of the important attributes of the product. However, before it's hydrated, there is going to be a change in viscosity. As it hydrates, it builds, the fiber swells, and the viscosity increases as a result. So the rate of viscosity or the rate of hydration increase will vary depending on the mixing process, the ingredients, the amount of shear that's involved. But to help try to reduce that time, that's what we recommend, trying to incorporate the Citri-Fi early into the formula, trying to incorporate it with some water or other types of moisture early to help swell and hydrate quickly. But shear would be another measure to try to expedite hydration. But once it's fully hydrated, typically that viscosity is very stable and will hold up quite effectively even through a heating process and freeze-thaw stability, as well as just over time. Long-term stability of viscosity is one of the really nice attributes of Citri-Fi.
Excellent. Well, that wraps up the questions, and I wanted to add one more thing before we close out the webinar. So we did have some technical issues during the webinar where it might have been very difficult to hear. So we will be re-recording this, and we will be sending a recording link out by way of e-blast. So if you registered and attended, you will be receiving this in e-blast in the next couple of days. So with that, I'm just going to conclude the webinar. Thanks everyone for participating, and we hope everybody has a great day.
Thank you.
Thank you.